Hello, class. Today for math, we're going to look at something kind of new in the way that the information is presented to you, but it's something that in your heart you know, and you'll see what I mean. Like, what, Mr. Woods? You'll see what I mean as we go forward. I want to start talking about factors, and I want to work on identifying factors for numbers. Usually when we look at a multiplication sentence, we have, three numbers, right? The multiplier, multiplicand, and the product. So, 2 times 2 equals 4. And these two numbers are factors. They're the numbers you multiply together to get the product, right? I've been saying it all year when we work with multiplication that the product is the answer to a multiplication problem. Today we're going to look at factors. Factors are, like I said, the two numbers you multiply together to get the product. And the reason this is important is because we need to, it helps with division especially, and 2 by 2 multiplication. If you know your factor pairs, a deeper understanding of the numbers that make up a product can help you look at it and go, okay, this is divisible by this, or this is divisible by this. So as we go forward today, this video is probably going to be a two-parter. First, I'm going to go through the concept of just looking at factors, okay? And I'm going to look at what makes up a factor, what makes up a prime number and a composite number. And then depending on how long this video goes, and it might be the next day's lesson, I'm going to build an anchor chart with you where we look at the, and it'll be something we build together. It's just going to be the definitions of prime and composite on the anchor chart. We're going to look at it more in depth. So first things first, we're going to look at factors. And we're going to do it using this array model here. I'm not sure how close up you guys can see of this, but I've got two different arrays. I've got stars here lined up in this straight row. And I've got 2 rows of 4 smiley faces. And I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. Now, how would I write this? That's 1 row times 8 stars equals 8, right? 1 times 8 is 8. 1 is always a factor of every number because you can always multiply 1 times itself and you'll still get, you'll get that number, right? So 1 times 8, 1 row of 8 stars. But if you come over here, I've also got 1, 2, 3, 4, 5, 6, 7, 8 smiley faces. But how are these smiley faces situated? Well, there's 2 rows times 4 smiley faces equals 8. Ooh. So they both show what? A product of 8. And they both show also the factors of 8. This is a factor. 1 is a factor of 8. 8 is also a factor of 8. 2 is a factor of 8. 4 is a factor of 8. And remember, these are the product. Okay? These numbers are multiplied to get 8. They are the product. So what we're gonna do is you guys are gonna commit to memory this notion of factors, this notion of products. Hopefully you remember product. I use that terminology with you a lot. You guys have been hearing it a lot of this probably all year long. Factor is a new term, but it's not anything that is crazy hard to remember. It's just remembering that a factor is one of the two numbers that you multiply to get a product, okay? 1 times 8 equals 8. 2 times 4 equals 8. But now, and you know what? Go back real quick, now that I think about it. Are those the only numbers that you can multiply to get 8? 1 times 8 equals 8. 2 times 4 equals 8. 3 times nothing equals 8. 4 times 2 equals 8. Nothing times 5 equals 8. Nothing times 6, nothing. So nothing else times nothing. No, these are the only numbers that you can multiply to get the number 8. Okay, record the multiplication sentences for each array. Over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 circles. Well, we have one row times how many circles? 18. Gives us a grand total of 18 circles. Factor. Say it with me. Factor. Factor. Product. All right. Now, I'm sure you can figure out by the pattern going on here how many is going to be here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 2 rows of 9, and we know 9 plus 9 equals 18. 2 times 9 is 18. Right? Savvy? And once again, these are the factors. Okay, 2 and 9 are the factors. 18 is our product. Oh, I think we're all done, aren't we? We'll just move on. Psych! Yeah, thought. Because look, are those the only numbers that multiplied together can equal 18? What do you think? What if I did this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I just put 18 dots there and I arranged them in what? 1, 2, 3, 4, 5, 6. 3 rows of 6. So that would mean that 3 times 6 equals 18. Woo! So then we want to order these in numerical order. If I said list the factors for 18, you would say 1, 2, 3, 6, 9, 18. And go 2 times 9, 3 times 6. Kind of looks like a smiley face there in the middle, doesn't it? A winky face. Yay! 3 and 6 is a factor of 18. 2 and 9, factors of 18. 1 and not 18. 1 and 18 are factors of 18. And now we've taken away the arrays here, where we're just going to look at this number. What are the factors here? 2 times 8 equals 16. What are the factors? 2 and 8, Mr. Royens. Absolutely. Good job, class. Actually, you know what? 2, 8. 2 and 8. What are the other factors of 16? Well, we could write another number sentence. Remember, always go to, if I ever say, quick, factor of that number, you can go 1 times that number and 1 in that number always. So 1 times 16 equals 16. So that means 1 and 16. So we have 2. Does 3 times anything equal 16? No. What about 4 times anything? Yeah. 4 times 4 equals 16. So 4 is a factor of 16. And what I can do here, so what are the factors of 16? 1, 2, 4, 8, and 16. One way I've always seen it, we can make like a factor rainbow. 1, 16. 2 and 8. And 4. I guess 4 can't really connect to anything because you only have to put 4 one time. You're not putting 4 twice. 4 is the same numbers, but you get what I'm saying. Pretty rainbows, right? Okay, now we're going to look at this number sentence here. 1 and 7. What are the factors here? 1 and 7, yeah. What else? Nothing, right? There are no other numbers you could multiply. Well, rational numbers. Maybe we could multiply some decimals and get it, but we're not the biz of that. So this is what is known as a prime number. A prime number. A prime number. Listen to me. Listen. Coming close. Put the microphone up to your ear so that you can hear my words. Okay? A prime number has only 1 and itself as factors. Okay? Now, the number 1 is considered an aberration, and you don't count that. But a prime number is any number that has just itself and 1 as a factor. You cannot multiply anything else to get that number. In this case, 1 and 7. Or the number 7 is a prime number, because the only way you can get the product of 7 is if you multiply 1 times 7. 2 times nothing equals 7. 3 times nothing equals 7. 4 times nothing equals 7. 5 times nothing equals 7. 6 times nothing equals 7. No numbers besides 1 and 7 will equal 7. That is a prime number. What's another instance of a prime number? What if I give you the number 5? What are the factors of 5? Well, 1 times itself, that's always a factor. 1 is always a factor of a number. 1 times 5 equals 5. What else? Nothing. 5 is a prime number. An Amazon prime number. Okay? Nothing else will give you the product of 5 besides 1 and 5. It's that easy to remember a prime number, guys. It is just 1 and itself. It's the only factors, the only numbers you can multiply to get it. Now, a lot of people make it, one common misconception I'm going to go ahead and address right now is that they'll say all odd numbers are prime numbers. That is false. Someone tries to tell you that, you say, eh. Because, yeah, 3 is a prime number because what times what equals 3? Only 1 times 3. So 3 is a prime number. So 3, 5, 7. Yeah, 3, 5, and 7 are all prime. But what if, because watch, 1 times 3 equals 3, 1 times 5 equals 5, 1 times 7 equals 7. Those are all prime. Nothing else besides 1 in themselves are factors. However, if, let me see if my notes make me go to, if I say, what about the number 9? List all the factors of 9. Well, 1 times 9 equals 9. Anything else equal? What other factors of 9 are there? 2 times nothing equals 9. 3. 3 times 3. 3 times 3 equals 9. So this is, even though it's an odd number, number 9, 3, 5, 7, 9. 9 is what's known as a composite number. And a composite number is any number. Well, okay, so stop and think. Let's be logical here, guys. Use your lovely brains. If a prime number is one that only has 1 in itself as a factor, what do you think a composite number will be? I'm assuming in your brains you were thinking a composite number must be a number that has, 2 or 3 or more factors. 2 or more factors. Or more than 2 factors. In this case, 1 and 9 and 3. More than 2 factors. More than 1 in itself. This has 1 and 9 and 3. So prime, only 1 in itself. Composite, more than 2 factors. Concept development. Now here, I believe, let me see my notes that I wrote down for myself. We're going to use a factor table. And factor table is going to look like this. Factor pairs, I'm going to just put FP 23. Okay. What are the factor pairs for 23? Well, 1 and 23, right? Remember, 1 and the number itself, they're always factors. So we got that. All right, good. We're off to a good start. 1, 23. 2 times 12 is 24. 2 times 11 is 22. No, not that. 3 times, no. 4, no. 5, no. 6, no. 7. So that means that 23 is prime. What about the factor pairs for 35? You know what, a little wider. Put FP again. Hope that's not too confusing, guys. I have FP up here, that just means factor pairs for 35. Okay. Factor pairs for 35. You already know, start off with 1. Keep it simple, guys. 1 and 35. What are the factors of 35? I know it. I don't want to teach you guys a skill or a strategy or secret that I'm sure you already know, but maybe you've forgotten in the depths of your brain with all the learning that's been going on in your life. If a number has 5 at the end, what's always 5 or 0? What's always going to be a factor of it? 5. If a number ends in 5 or 0, there's always going to be a 5 will always be a factor of it. Okay? So, with that rule in place, 5 times what will give me 35? 7, right? 5 times 6. 5 times 6 is 30. 5 and 7. Nothing else. You don't have to go down and say 7 times 5, though. I guess I wouldn't count you off for doing that little extra work there. But it's the same as saying 5 times 7. Okay. And the last one here. 48. The factor pairs for 48. We always start off with,
we're number 1. We're number 1.
1 and 48. I told you a divisibility rule earlier. I think it was, I don't know if it was the lesson yesterday? Lesson Thursday, maybe? If a number ends in an even number, so like 0, 2, 4, 6, 8, it's always going to have 2 as a factor. Because you can always split it in half. So the question is, what's half of 48? 2 times what will give me 48? Well, 2 times 12 is 24. 24 is half of 48. So 2 times 24. What else? Well, 3 and 16. Because 18, 2 times 3 is 8, 48. Now, you may have to do some skip counting, guys. If you don't know, then I always suggest just thinking about, start at 1. 1 times that is 2. Skip count by, maybe skip count by 3s. Go 3. What about 4? 4 is actually a factor of it as well. 4 times 12. You should know your 12s, right? Right. See. Oh. 3 and 16. 4 and 12. 4 times 12 is 48, guys. That should be a no. That should be a fact you know. 4 times 12 is 48. Okay. Now, based on the rule I told you about 5s here, if it has a 5 or a 0, so 5 will always be a factor. Is 5 going to be a factor? No. However, what about the number 6? Hopefully you're going, I already said 6 in my head, Mr. Williams, because I know 6 times 8 is 48. That's one of my favorite math facts, just because you can say that 6 times 8 is 48. Say the number 8 right there. Okay? 7, no. 8 times 6, graded 8. 9, no. 10, no. 11, no. 12, well, we did 4 and 12 there. That's it. Okay, look at all those factor pairs for 48. Yeah, that's a lot of them, I know. Now, my question is, are these two 35 and 48, are they prime or composite? Composite, right? Because they had more than just one in itself as a factor. That means that 23 is prime. Okay? So guys, the work that you're going to be doing is this problem set. And you're recording factors of the given numbers as multiplication sentences. And when I say multiplication sentences, look at the example here. Has number 4. It says 1 times 4 equals 4. 2 times 2 equals 4. Those are multiplication sentences. So 6. 1 times 6 equals 6. 3, I guess I should do 2 times 3 since I want to keep it in numerical order. 2 times 3 equals 6. Then the factors of 6 are 1, 2, 3, and 6. Because remember, guys, please remember, a factor are the numbers you multiply to get a product, okay? And then the P or C means, is it prime or composite? Well, there's 4 factors there, so I know that it is C for composite. If I look at this one, number sentences or multiplication sentences for the number 7. 1 times 7 equals 7. Nothing else equals 7. If you watch the lesson, you know. Factors of 7 are 1, comma 7. Is that prime or composite? Prime, right? Because it only has 1 in itself. Boom! It's not super difficult, guys. You just have to apply yourself and think about your learned multiplication knowledge, division knowledge, okay? Awesome. If you need me, please email me and let me know, okay? Good luck, guys.